Hey folks, how's it going? This is Mr. Murray coming to you today with a little video for Course 1 Honors for Wednesday, May 13th, 2020. So it's another little do now video in which we're going to practice graphing exponential functions, and there's going to be a little bit of analysis as well. Okay, so here what we need to do, we need to complete the table and the graph as we've been doing for the past few days. I encourage you to take a look back at those do nows if needed. Our function is f of x equals negative 1/2 to the x minus 2 minus 3. So go ahead, pause, make your table and your graph. Then when you're ready, unpause, and you can see what I got. All right. So here what we want to do, I'll just go down to this one. Here what we want to do is let's start by plugging in some numbers. So I'm going to start by plugging in 2 because 2 minus 2 is 0. Negative 1/2 to the, positive 1/2 to the 0 is 1. This makes it a negative 1. And you subtract 3 for a negative 4. So you have 2, negative 4. Now I'll plug in 3. When I plug in 3, okay, 3 minus 2 is 1. 1/2 to the power of 1 is 1/2. This makes it negative 1/2 minus 3, negative 3, and 1/2. Okay, I'll plug in 4, why not? So 4 minus 2 is 2. 1/2 to the power of 2 is 1/2 times 1/2, which is 1/4. This makes it negative 1/4. This makes it negative 3 and 1/4. And what you'll see is if you plug in 5, now if we just compare this to regular negative 1/2 to the x minus 3, okay, what we would get is this would be, and I think actually 5 will be to the 8th, right? Because when you do 5 minus 3 is, 5 minus 2 is 3, 1/2 to the 3rd is an 8th. It's the 8th. So it's actually good because it let me correct a couple of potential issues I had there. An 8th. So what you can see is there's a shift, right? Plugging in 4 to this function is the same as plugging in 2 to this function. Plugging in 5 is the same as plugging in 3. Okay? Plugging in 2 is the same as plugging in 0. So you can see there's a shift to the right, right? Because the values here with the same number as the black and the red are moved over 2 to the right. So whereas you'd ordinarily need 2 to get that value, here 4 will give you the same value. So it'll be to the right, right? Because 4 is to the right of 2. Okay? Now, anyway, let's continue. So we'll plug in 1. 1 minus 2 is negative 1. 1/2 to the negative 1 is equal to 2, because it's 2 over 1 to the positive 1. So that's 2. That makes it a negative 2. It makes it a negative 5. And I've got a feeling that the next one will be off the graph, but let's see. 0. 0 minus 2 is negative 2. 1/2 to the negative 2 is equal to 2 to the positive 2, because you flip and then it becomes positive, which is 4. That makes it a negative 4. Minus 3 is negative 7. Okay, the next one definitely will not be on the graph, but I guess I misspoke before. So if we plug in negative 1, we're going to end up with 8. If you haven't seen the pattern, it'll be to negative 3, which will be 2 to the positive 3. You flip, and then you flip, and then it will be negative 8 minus 3, which is negative 11. So probably something like this. All right, and then on the other side of things, we have 2 done. It's -4. We have 3. That's -1, 2, 3.5. Then we have 3.25. Then we have 3.125. So what looks like is happening is we're getting a graph that looks something like this. And again, you can probably do a better job than me, but it's leveling out at that -3. Okay, so you got something like that. So remember, when you're graphing, you only need to graph the stuff that fits within the window. And once you see the trend, the number it's going to, you can start to level off. So you notice I'm not going to plug in 6, 7, 8, 9, 10. I can see it's going up and it's starting to level off at -3. So I'm good to go there. Okay, as I'm not going to be super picky about your graphs, as long as the horizontal asymptote is obviously it's got to be correct and it's got to be clear where that asymptote is. Your arrow should be flattening out. It should not be pointing up. It should not be pointing down. It should be making it clear that it's leveling off. Okay, so some things we notice. 1, the negative sign. A negative sign, right? Because here's the deal. Let me just pull up this. I'm going to make this line green. Okay, and let's make it dotted just so we can get I'm going to make it a little bit thinner and I'm going to make it dotted. Here's our asymptote here. Okay, so notice negative below the asymptote, right? Versus whereas if it was positive, we would have been above the asymptote. So above versus below the asymptote, right? Because for example, if this was a positive 1/2 to the x minus 2 minus 3. For example, plugging in 0 would give you 1 instead of that, whatever you got there. Plugging in 2 would give you -2 instead of that. Okay, plugging in 1 would get you -1 instead of that, and so on and so on. And then plugging in, right, you can imagine it with this 8, if you hadn't made it negative, you would have gotten 5. So this is what happens. If that had been a positive, and like a positive 1 instead of a -1, right? See how it would have been above the asymptote instead of below the asymptote. So again, negative in front of the B value. So a negative below horizontal asymptote, right? Because a is -1. Okay, notice the connection here. -3. What's the equation of the horizontal asymptote? Y equals -3. Okay. The last thing we'd want to think about is the transformations that are going on here. So I'm going to briefly erase this. All right. My apologies. I'm kind of sneezing here a little bit, trying to practice safe sneezing procedures. Okay. Now, if I was to graph 1/2, if I was just to do 1/2 to the x, that's going to be our so-called parent function. Okay, so what we'd get is, we'd get something like this. Okay, it's actually the opposite of 2 to the x in a sense. You can see its asymptote is 0. Okay, so if we think about this, let's take a look at a point. Let's take a look at, let's say, our y-intercept, the number we get when we plug in 0, right? So if we think about it, what would I have to do to get that y-intercept to change? Well, there would have to be some kind of reflection, and then there would have to be some kind of movement, okay? So the corresponding point, what makes this 0, is this point right here. So if you think about, if we first reflect over the x-axis, I'm I'm going to get an orange color here. Then move over 2 to the right. And then move down by 3. We'll be right on top of the corresponding point. Okay, so we also want to make sure we're thinking about transformations from the corresponding parent function. The parent function is generally just simply f of x, and you make a1, you don't put any h, and you don't put any k. It's just b to the x, whatever your corresponding b value is. Okay, so I'm going to do a little bit of analysis, and then we'll wrap things up, because I know this is a longer do now video. We're going to look at the black function here for this analysis. So the domain here is negative infinity to infinity. The range is negative infinity to negative 3. Again, notice the horizontal asymptote. The y-intercepts, there's rather x-intercepts, there are no x-intercepts. There is a y-intercept of 0, negative 7. Remember, every exponential will have a y-int, because if you say the domain is everything, then you should be able to plug in 0. Okay, it's increasing along its whole domain. Remember, either increasing or decreasing will be everything. So it's decreasing nowhere. Its horizontal asymptote, you need the full equation, y equals negative 3. Horizontal, you should associate with y equals. Where is it positive? It's never positive. I know that because it starts negative and it never goes above negative 3. And it's negative everywhere on its domain. Finally, end behavior, as x goes to negative infinity, f of x goes to negative infinity. In other words, the limit as x goes to negative infinity of f of x equals negative infinity. And as x goes to positive infinity, f of x goes to negative 3. So, in other words, the limit as x approaches positive infinity of f of x is negative 3. Remember, you can do either or. So either, if you want it short and sweet, do the limit, fine. You want to use words, do the as, and just don't mix limits and the as. Either do the words or the limits, your choice. Either one, completely mathematically correct, completely acceptable. Okay, so hopefully you're able to get these right. Today what I'm going to be doing is I'm going to be offering you a little bit of an opportunity to practice with analysis. So please make sure you take a look at the materials for today for your 2 analysis graphs and analysis sets of questions. Okay, and please make sure you're able to do those. Make note of any questions you have. Best of luck. Don't forget to love math. And remember, you can do it. All right, thanks again for watching, and have a wonderful day.